This is R.d.sharma solution, class 12. Chapter 19, exercise 19.25, we are taking of indefinite integrals. Now this sine inverse x divided by x square. So we have a sine inverse. We have to first of all get rid of this inverse. Then only we'll be able to integrate it properly. So we'll put x equals to sine theta. When we take x equals to sine theta, this theta will become sine inverse x. When we differentiate this, dx by d theta will give cos theta. That means dx will be equal to cos theta d theta, because ultimately we have to do something for dx as well. So dx will become cos theta d theta. Now we'll integrate it. And sine inverse x, because sine inverse x is theta, so we'll write theta. Dx will be written as cos theta d theta. Now how about x square? X square is what? X was taken as sine theta, so it will be sine square theta. So let me write sine square theta in the denominator. Now what is the benefit of doing this? We will separate these two terms or multiple terms. Theta will write like that. We have a cos theta, so we'll have a sine theta in the denominator. Then cos theta we have utilized. So only sine theta is left in the denominator. So we have a theta. Cos by sine will give you cot theta, and 1 by sine theta will result in cosec theta. And we know the differentiation of cosec theta. It's cosec theta cot theta. You already know that. An integration of cosec theta cot theta can also be done. So there are two ways we can approach it. So now comes the decision of taking which one the first one and which one the second one. So we'll take the theta as the first function and cosec theta cot theta combined as the second function. That means this all as the second function and theta of course the first function. So I am applying the formula now. Theta first function integration of cosec theta and cot theta minus integration of d by d theta of what? Theta, and again the integration of cosec theta and cot theta, and all of this which is on the right you see will be integrated again. Now theta, what is the integration of cosec theta cot theta? It will be negative cosec theta minus integration of d by d theta of theta will be 1. Again integration of cosec theta cot theta is negative cosec theta, so I'll make it as a positive now. So cosec theta cot theta remains inside and integration will form cosec theta. Now we know the integration of cosec theta as well. So the final step will be something like this: minus theta cosec theta. And the integration of cosec theta, as I just suggested, it has a direct result. What is the direct result? It's log base e. You can write it as ln and modulus cosec theta minus cot theta, and then with the constant of integration. I told you the final step of theta, but we still need to convert it into in the terms of x. Let us first resolve it. Theta cosec theta can be written as 1 by sine theta plus ln cosec theta minus cot theta can be written like this. Cosec theta is 1 by sine theta minus cot theta will be cos theta by sine theta, and this will be 1 minus cos theta by sine theta. Since sine theta was taken as x, cos theta has to be converted in terms of sine theta. So you can write cos theta as under root 1 minus sine square theta, and in the denominator you have sine theta. So let me write it here in full terms: 1 minus under root 1 minus sine square theta divided by sine theta with a modulus end and constant of integration. So let's replace now the theta with the term of x. Theta is what? It's sine inverse x already mentioned. So theta will be written as sine inverse x. In the denominator it is sine theta, which can be written as x, plus the ln log base e modulus 1 minus under root 1 minus sine square theta. What is sine square theta? It's x square, and divided by sine theta. What is sine theta? It's x. So let's write x here plus constant of integration, and this result is your final result. So this is how you are going to go about it. Solve it the way I presented it to you and explain all through, and this is the reference for those who want to solve by themselves. Now in this question, tan inverse x differentiation will give you 1 by 1 plus x square. So that kind of thing will be in your mind while solving this question. X square is already there in the numerator, so we need to get rid of this x square first. How to do that? We have a 1 plus x square. We have a x square in the numerator. So we can write x square as x square plus 1 minus 1. Why? Because 1 plus x square is in the denominator. So let's write x square plus 1 minus 1. In the denominator is 1 plus x square. And tan inverse x, you can write it as separately. And you have a dx here. So integration of this. So let me resolve it first. So it will be x square plus 1 divided by 1 plus x square minus 1 by 1 plus x square. And please remember, tan inverse x is multiplied to both of these terms. So let me write tan inverse x here with a dx integration. Now this goes 1. This will become 1 because it gets cancelled. Tan inverse x will be multiplied. So first term will be tan inverse x dx. And the second term will be minus integration of tan inverse x divided by 1 plus x square, which actually we intended, we wanted. Initially I told you tan inverse x differentiation is directly 1 plus x square, which we will employ or use just now. For tan inverse x, we have to apply the same scheme which this exercise wants us to do. We cannot integrate tan inverse x directly. So we need to have another function. What can be the another function? Call it as because I'm calling it as a and b, so that we can just integrate a and then we'll follow the scheme. We ought to have a 1 along with a tan inverse x, so that we have two functions, because integration is possible with two functions, and then we can apply the formula we have learned earlier. We'll call tan inverse x as first function and the 1 as the second function. So tan inverse x integration of 1 dx minus integration of d by dx of tan inverse x, and then again the integration of 1 dx, and then final will be the integration with respect to dx. Now this 1 dx will be simply x, and tan inverse x is already there, minus tan inverse x differentiation is 1 by 1 plus x square. So we have 1 by 1 plus x square here. Integration of 1 is x only. So we are integrating x by 1 plus x square. So for a, which I just designated a as integration of tan inverse x, x tan inverse x is already being the first term, which is a clear term which you can write. Now integration of x by 1 plus x square, it's quite simple because 1 plus x square can be taken as t. When you take this as t, dt by dx will be equal to 2x. So dt by 2 will be equal to x dx. So this x dx can be written as dt by 2. So this is dt half, you can bring outside. So dt by t half log modulus of t plus constant of integration. See, constant of integration will come everywhere. You can just combine them in a simple one constant of integration. So now replace t by 1 plus x square. Half log 1 plus x square is there. Negative is already there. So I am now writing the final term. Minus half log 1 plus x square. Now the b, which I designated as b, that needs to be solved. And it's quite simple because tan inverse x, directly we have dx by 1 plus x square. So I'm showing it to you here now. Take t equals to 1 plus x square. Since we have already taken t, let's take it as p. It's just same as what we have done. So p equals to tan inverse x, dp by dx will be 1 by 1 plus x square. So dp will be equal to dx by 1 plus x square. So this integration will become something like this. We have taken tan inverse p, I'm writing p, and dx divided by 1 plus x square can be written as dp. So just have to integrate p dp, that is x dx, so it will be x square by 2 p square by 2 plus a constant of integration. But what was p? P was taken as tan inverse x. There is a negative in front, so I am writing negative, and p square by 2 p was tan inverse x, so tan inverse x whole square divided by 2. All of the constant of integration we combine and then just call it as a constant of integration plus c. So I told you each and every aspect of this question, that is every part which has to be integrated separately, and that's your final answer. Now how to do this, it's in front of you. It's a good question. Let me tell you first. And the written material, what you see here, reference, is your responsibility. I can tell you how to solve this, logic, reasoning, but the writing is your responsibility, that you have to follow very clearly and very diligently. In the previous questions, one of the questions I told you that there will be a formula of cos 3 theta and sin 3 theta. So we have here cos inverse 4x cube minus 3x. That means in order to get rid of this inverse, we need something inside. So it's directly, because I know this and some of you also might be aware that this is simply a formula of cos 3 theta, because if you place x equals to cos theta, that means theta equals to cos inverse x will become, when you differentiate this, dx by d theta will give you minus sine theta. That means dx will be equal to negative sine theta d theta. Now let me revisit here. Cos inverse is already there. Now 4x cube, that is cos cube theta minus 3 cos theta. Now 4 cos cube theta minus 3 cos theta is the direct result of which gives you cos 3 theta. So cos inverse cos theta eventually we got. You can cancel this cos and cos inverse. You'll get 3 theta here. Ultimately, what you are integrating, because cos inverse 4x cube minus 3x we have gotten as 3 theta. So let me write 3 theta here, but you have to do something for dx as well. And we have already in preparation done that, minus sine theta d theta in place of dx. So write minus sine theta d theta here. Now this negative and the constants, they may create certain problems. So my advice is for you is always to keep them away from you as much as possible. That's what I'm doing here. Negative 3 I'm taking outside and theta sine theta inside. So this is actually the beginning of this question, because all other things were just resolving and getting to a point where we can actually use the formula which this exercise or this question needs. Negative 3 we'll use in a short while. Now you tell me which has to be taken as the first function and which one has to be taken as the second function. Of course, you got it right. It's theta as the first function and sine theta as the second function. Now let's apply the formula now. So we have a theta here, integration of sine theta d theta minus a differentiation of theta, and then integration of sine theta d theta. Then inside this, all done, it will be integrated again with respect to d theta. So sine theta is minus cos theta integration. So we are writing this. Again sine theta will be minus cos theta. So I am making negative as positive. D theta by theta will only be 1. So we have to integrate what? It's cos theta. And you already know the integration of cos theta. So negative theta cos theta, integration of cos theta will be sine theta and plus a constant of integration. So this is in terms of theta, and this theta was introduced by us. So we need to get rid of it, and negative 3 is already there. So let's multiply negative 3 to all of these terms. So you'll get a 3 theta cos theta, negative 3 sine theta, and negative 3 multiplied by c, or whatever constant is multiplied by c, it will always be c, because we don't know it. It's just a constant of integration. Now the replacement has to be done. We already know x, which is cos theta. We already know theta, which is cos inverse x. So cos inverse x is theta. Wherever theta is there, we'll replace cos inverse x. Wherever we have cos theta, we'll replace it by x. So 3x cos inverse x minus 3. But we don't have sine theta. So we have to use a formula. Sine square plus cos square equals to 1. Sine will give you under root 1 minus cos square. And this under root 1 minus cos square is 1 minus x square. So under root 1 minus x square plus a constant of integration. So this is your final result. Now I always try to show you the reference, because there are certain things which some people might not understand, they might not get. So there is always a reference in front of you, so that you can, whenever you're solving, you can just follow this. And main thing is the formula of 4x cube minus 3x, which comes down to your cos 3 theta. Now this question and the upcoming question, they have the same ambience or same way of approach. What does it mean? We need to get rid of cos inverse anyhow. If it would have been sine inverse, we need to get something cancelled. So we need some cos terms which can replace 1 minus x square by 1 plus x square. Because we need to cancel this cos inverse, and that can only be cancelled with cos. So what will be the replacement? In inverse trigonometry, it's a direct result. That means this cos inverse 1 minus x square by 1 plus x square is directly 2 tan inverse x. It's just twice of tan inverse x. So you are ultimately integrating twice at tan inverse x here. And you are quite aware of integrating tan inverse x because we have integrated it, I think 6 to 7 times. So 2 integration of tan inverse x which we are doing here, because cos inverse 1 minus x square by 1 plus x square. Let me reiterate, it's just 2 tan inverse x from our previous knowledge of inverse trigonometric functions. Now tan inverse x cannot be integrated like that. You have to have a 1. So the first term will be tan inverse x will be taken as the first term, and 1 can be taken as the second term. So tan inverse x, then integration of 1 dx minus integration of d by dx of what? Tan inverse x, and then the integration of 1 dx, and this whole will be integrated again. So we have a tan inverse x. Please watch carefully because there are certain questions which will be we will be integrating integration of tan inverse x. So d by dx of tan inverse x is x by 1 by x 1 plus x square. Integration of 1 dx will be x, and we have already done this x by 1 plus x square in just 1-to-1 previous question. Okay, so I'll just write the direct answer here. 2x tan inverse x is already done. I don't want to waste your time. You already know x by 1 plus x square. So let me write the direct result. It is ln 1 plus x square in the modulus. So if you still have some trouble, then you can follow this scheme. This is the way you are going to write it. Please remember, tan inverse x will be coming again and again, now and then. Now integration of tan inverse x, as I said, you already know that. Oh, I already know that. You will just say that because there are so many questions we have completed and done this integration of tan inverse x repeatedly. This tan inverse 2x by 1 minus x square is nothing but it's just tan inverse x. To your surprise, it's just 2 a tan inverse x. In the previous question we had just seen cos inverse 1 minus x square by 1 plus x square, it's 2 tan inverse x. Similarly, tan inverse x 2x by 1 minus x square is 2 tan inverse x. So I hope that you will not waste your time. And without wasting your time, let's show you the reference which you can just follow. This question has already been done, and this is the proper reference to this question if you know that it's just 2 tan inverse x. Now x plus 1 into log x. Now the main condition is how we will decide which will be the first function and second function. Integration of log x will be difficult. So in view of that, we will decide which one we will take as the first function and the other function. Integration of log x will be a problem for us. That's why we'll take log x as the first function, x plus 1 as the second function. I am applying the formula now. Log x as the first function, log x integration of x plus 1 dx minus integration of d by dx of log x integration of again x plus 1, and this is in terms of dx. So this is log x plus 1 will be x square by 2 plus x. That means you can just do it like this. X plus 1 dx can be integrated like this. You can separate these two terms, x dx and 1 dx. X will give you x square by 2 and 1 dx will give you x. So write it here, x square by 2 plus x minus integration of d by dx of log x will be 1 by x, and x plus 1 we have just done it. So you can directly write without again integrating x square by 2 plus x, and this in terms of dx. Now if you multiply this x with x square by 2 plus x, what are you going to get? It will be x by 2 plus 1, and let's integrate it now. X square by 2 that is x square by 4 plus x. Now just write it here. There is no other catch here. This question is very straightforward. X square by 2 plus x I am writing in front, then we have a log x minus, and just subtract these. So minus x square by 4 minus x plus constant of integration. This is your final answer. So that's how you are going to go about it. Don't forget to write English things here, English sentences here. This we will take in the next discussion. Till then, thank you so much and have a good one.